Okay, this is the video for page 8, dispersion. This is an additional page because in the new syllabus there are some additional terminology and concepts that you should know about. So, first of all, let's read this top part. This is actually, you already know it about how to draw a box and whisker plot. You know that you need a 5-number summary, which is minimum, first quartile, median, third quartile, and maximum. But now they have 2 new names for first and third quartile, which they've used in the past, but they didn't use these abbreviations. So there's lower quartile, which is the same as first quartile, and they abbreviate that LQ. And then the upper quartile, they abbreviate UQ, is Q3, is the third quartile. So that's nothing new. It's just in case you see UQ or LQ in some place, don't freak out. Know that that's Q1 and Q3. The next concept, which I don't think you're going to use this too much in your exam papers. Probably you're going to see it, or you're going to use it more in maybe your IAs. Basically, they're defining with a math quantified borderline or limit what an outlier is. Okay, because like visually, we often say outlier in science and math when we see a data point that's like kind of far away from the rest of the cluster of data points. But in IB Math, they define an outlier to be something that's a certain amount, a certain distance away from the upper quartile or lower quartile. Obviously, it's going to be a certain amount above the upper quartile or a certain amount below the lower quartile. How do they define this distance? Well, what they do is they take the IQR, which is basically the width of one of these rectangles of the box and whiskers plot, and then they multiply that by 150% to make it slightly longer, and then they put that distance next to it to see how far away the farthest point away is. Okay. So, do you see the width here? Let's say that we make that 50% longer, which would be, I don't know, about this far, okay? And then we set that next to the red region on the right side, and we sit it next to the red region on the left side, and then we check to see if the whiskers of the box and whiskers extend past that, and they do, don't they? So since they do, then maybe the points in the yellow region are outliers. Let's do the same thing for the girls' distribution here. So if this is the width of the rectangle in the girls' distribution, and like 150% would be about that far, let's draw 150% here and 150% here. And you can see that probably there's a region here maybe that is also an outlier. We would need to actually use numbers to figure out exactly if that's the case, but visually we can kind of see that the right whisker of the boys plot is maybe more than 150% away from the main rectangle, and same with the girls on the right side. Okay, so we're going to do that in a problem to see if that's really the case. Next concept, which we didn't really talk about in the old syllabus, is symmetry in the box and whiskers plot. That's kind of an obvious thing, right? It's like if you look at the box and whiskers plot and you want to know if it's symmetric, what you do is you consider the median to be the center, and then you check, okay, what about the Q1 and the Q3, or the LQ and the UQ? Is it kind of equidistant from the median? Is it about the same distance to the left and to the right? Usually it's kind of hard to tell with the upper quartile and the lower quartile. They're kind of like so close to the median typically that, you know, with these short distance, how can you judge visually if they're really asymmetric, if they're not symmetric, right? But usually with the whiskers, it's a little easier to tell, right? And it's a lot easier for a distribution to become asymmetric because, like, basically if you have one point that's really far to the left or to the right, that will immediately make it asymmetric, right? And so, like, if you look at the boys plot here, obviously the right whisker is much longer than the left whisker, so you would say it's not symmetric. And the reason why it's not symmetric is because there is a data point, looks like 19, which is much farther away from the middle 50% than the lowest time, which is 10, right? Same with the girls. If you look at the middle of the girls here and you look at the left edge and the right edge of the plot, the right edge is much further away from the middle than the left edge, so obviously it's not symmetric. So a lot of times, maybe for one of the marks in the box and whiskers question, they might ask you if the distribution is symmetric, and they'll ask you to justify why you say that, okay? All right, so let's do a couple problems. Data on the shoe sizes of a group of students is shown in the table. So this is kind of an unusual data table because it's got 3 rows instead of 2. Remember how I always said that, probably in 90% of the cases, they're going to have first row be X and the second row be frequency list, right? In this case, you have 2 frequency lists because, like, instead of making if they wanted to make it easier for you to understand, maybe they would make 2 data tables using X and FL1. They would make 1 data table, and then they would use X and FL2 to make the second data table, and then it would be clear how you would graph each one because it would be just like any other problem. In this case, they're making it a little bit more challenging because they put the frequency list for 2 different distributions underneath the same X values. So what are the X values? They're shoe sizes between 34 and 49. And let's see, we're going to draw a box and whisker plot for the females and the males and compare the 2 plots. Remember, to do a box and whiskers plot, what we need is the we would need the 5-number summary, min, max, Q1, Q3, and median, and we would need that for both of these. So what I'm going to do first is I'm going to, into the calculator, I'm going to type in this into L1, I'm going to type this into L2 and this into L3, and then first I'm going to do a 1-bar stats with L1 and L2, with L2 in the frequency list. Then I'm going to do a 1-bar stats with L1 and L3, also with L3 in the frequency list. And then that is going to give me the 5-number summary for each, and that will allow me to draw the box and whiskers plots and look at the symmetry and outliers and try to answer those questions too, okay? So I'm going to go offline and I'm going to type these into L1, L2, and L3, and then I'll come back to L1, L2, and L3. Now I'm going to do stat calc 1-bar stats on the first distribution, which would be L1 in the list and L2 in the frequency list, and then I'm going to see what my 5-number summary is. It's in the second page of data mainly. So I'm going to write my 5-number summary in the order from left to right. So it's going to be 34 is the minimum, 37 is Q1, 38 is the median, 39 is Q3, and 40 is the maximum. And then I'm going to do the same thing for the second set of data. So I put L1 for the list and I put L3 for the frequency. And then I put minimum 37, Q1 38, median 39, 40 for Q3, and 49 for maximum. Okay, so now I'm going to draw the box plots, and so for the females I will use red, and for the men I will use blue. And so the females, it would be 34, I'm going to just put my horizontal, my vertical lines first. 37, 38, 39, and 40. And then I draw a rectangle around the middle 3, and then I draw whiskers between the other 2. And then now I'm going to do the boys. So 37 is the first of the 5-number summary. Then 38, 39, 40, and then 49 is the rightmost one. And I draw a rectangle around that. And my whiskers. So those are my box plots. And are they symmetrical? I would say for the girls, it's you know, a little bit asymmetrical. I think that the lower shoe size of 34 is much less than the median compared to the upper shoe size. So it like extends more to the left. The male distribution is obviously not symmetrical at all with there's a data point at 49, which is way to the right? So comparing the girls' distribution and the boys' distribution is not symmetric at all, okay? Now it says to comment on whether there are any outliers. Obviously, from looking at it, you can see kind of that this is an outlier, but we actually want to figure that out with quantitative methods. So what we're going to do is, like, let's take the red distribution first. Let's take our 5-number summary, and the main part of the 5-number summary that we use to figure out our boundary is Q1 and Q3, or LQ and UQ, which are 37 and 39. If we subtract the two, we find out that it has an RQR of 2. If the IQR is 2, what is the tolerance that we add to the right and the left of the rectangle? It's 2 times 1.5. So my tolerance for outliers is 3, okay, because it's 1.5 times 2. And then what I'm going to do is I'm going to add 3 here, see where that goes, and I'm going to add 3, or I'm going to subtract 3 from there, see where that goes, and then we'll see if all the data points are within the tolerance. So let's see, for the red distribution, basically the limit for the tolerance is going to be 39 plus 3, which is 42. And then the lower boundary for tolerance is going to be 37 minus 3, which is 34. So let's see, are there data points that are smaller than 34 or greater than 42? Not smaller than 34, because 34 is the smallest. Not larger than 42, because 40 is the largest. So basically, for the girls' distribution, I'm going to erase all these marks here to not confuse you. For the girls' distribution, there are no outliers, right? Because according to our boundary of an extra minus 3 and an extra plus 3 around the rectangle, there are no outlier points, so there's no outliers in the red distribution. What about the blue distribution? I'm pretty sure that there is going to be one. So for the blue distribution, what we do is we do the same thing. We take our Q1, which is 38, and we take our Q2, our Q3, which is 40. We take our upper quartile and our lower quartile, we subtract them. It gives us an RQR of 2 also. And then again, how do we find the tolerance? We multiply 2 times 1.5, which gives us 3. And then so we're going to look at the rectangle and we're going to say, okay, we're going to add 3 units to the right. Are there points that are farther away than that? We're going to subtract 3 units from the left. Are there points farther away than that? So we're going to take our 40. We're going to add 3 to it. And that'll give us 43. That'll be our upper boundary tolerance for outliers. Let me rewrite that 3. And then we take our lower quartile, 38. We subtract 3. That gives us 35. That would be our lower boundary. So is there any data that's lower than 35? And the answer is no, because the smallest shoe size for males is 37, so there's no outliers on the left side. What about on the right side? We're going to add 40 plus 3, we get 43. Are there any data points that are above 43? Yes, for sure, because the maximum value is 49. Anyone else? No, because like this shoe size is obviously above the tolerance of 43. But the next biggest one, which often happens with outliers, sometimes outliers are like 1 or 2 points only that are way to the outside of the distribution. So if we look at the next farthest one, it's 42, and 42 is within the tolerance. So there's only one data point that is actually an outlier, which is 49 for the boys, and for the girls, none. Then it says to draw the box plots again, showing out any outliers clearly. Outliers are represented by crosses. Okay, and so when we draw the outlier now, what we're going to do is we're going to draw the 49 as a cross, and then we're going to redraw the box and whiskers so it only extends to the next largest point, which is 42. So instead of the way it was, where it had this huge whisker, now it just extends to 42. Okay, now when you look at the box and whisker, it looks more symmetrical, right? But when they ask you if it's symmetrical or not, you still need to consider the outlier point, because as I might have mentioned previously, in your IA, you may not discard outliers just because they are far away from your data. The only reason why you can discard an outlier data point in your IA is if there was some kind of measurement error. Okay, and then you would need to explain what that measurement error was. All right, let's go to the last problem. So this data shows the time it took in minutes for 35 students to complete a Sudoku puzzle. And of course, they gave it to us completely out of order, which is just creates a little bit more work on your part. You have two possibilities for how you input this data into your calculator. Just like before, we need to put it in our calculator to easily find our 5-number summary. If you were going to do it manually, obviously you're going to put all these in order. If you were going to make L1 and L2 with a frequency table, obviously you want to put everything in order. But if you just throw everything to L1, you don't need to put it in order. And so I think in this particular case, in your IA, you want to do that, because in your IA, you definitely want to make a frequency table. But in this particular case that you're just trying to solve the problem, maybe the easiest way is to simply input all this data in the order that it is, and then you don't need to sit there wasting time putting everything in order, which is actually would take quite a bit of time. So let me do that. I'm just going to input all this into L1, and then I'll be back in a second. I'm back. I put all these numbers into L1. It's really difficult to do that completely correctly. One way that you could use to make sure it's like just a real quick check is to like check the N number in the 1-bar stats display to see if it matches the number of numbers here, which is 35. Okay. Anyway, I put everything into L1. I go to stat calc 1-bar stats as usual. And then when I go into 1-bar stats, I want to put list as L1 and then frequency list blank, of course. And then I go down to calculate. And then I'm going to get my 5-number summary, which is going to be 6, 12, 16, 21, 43. 6, 12, 16, 21, 43 is my 5-number summary. So I found median, LQ, UQ, and it also asked me for mean and range. Remember how to find range? So range is equal to the max minus the min, which would be 43 minus 6, which would be 37, right? So the range is 37. And then the mean, we're going to go up and look at the top of the display here, because it's X bar right at the top. It's 16.9 when I round correctly. So the mean is going to be 16.9. Notice that the mean is pretty close to the median. That's usually the way it works. Determine whether there are any outliers. So outliers, we determine the outlier tolerance by finding the IQR first. In this case, the IQR is equal to 21 minus 12, which is equal to 9. And then we take 1.5 times the IQR in order to find the tolerance. It's 1.5 times 9. 1.5 times 9, if you do it on the calculator, is going to be 9 plus 4.5, so it would be 13.5 would be the tolerance, and you're going to add and subtract the 13.5. You're going to add it to UQ, and you're going to subtract it from LQ, and that'll give you the boundaries. And like you can see that like when you subtract 13.5 from 12, it becomes negative. So that's like so low that obviously none of the minutes it took is going to be less than that, because that would be, we don't have any negative times. That's not valid in this particular case. And then if you add these two together, it gives you 34.5. So that would be the upper boundary. How many students do we have who exceeded 34.5? Maybe only the one who got 43. Do you see any other numbers here that are greater than 34.5? Oh, there's the 35. So we got 2 students who went over 34.5 minutes. And I looked through the rest, and yeah, that's it, okay? And then remember, to make the box plot, normally what you do is you mark all 5 numbers with vertical lines. So we do like 6, which is about there. We do 12, which is about there. We do 16, which is about there. 21, it's about there. And 43 would be about there. And then we enclose our rectangle, and we connect our whiskers, except for the fact that, remember, we're going to mark our outliers with X's instead, or with crosses, as they say in the book. And one of them is going to be 43. That's going to be one of the crosses. And then the other cross is going to be 35, because 35 is slightly to the right of the boundary of 34.5. And then what is our third biggest number? After 43 and 35, I see a 26. Is that the third largest? I don't see any other 30s. It's very inconvenient that they didn't give it to us in order, isn't it? So the third number looks like it would be 26, if I'm not mistaken. So I'm going to mark the fifth vertical line at 26, which would be about there, and then I'll connect that with a whisker. So that would be my box and whisker, and then I have 2 extra points, which are outliers that are outside of the boundary. Okay, and remember, the way we found the boundary is we added the tolerance to the upper quartile, and we subtracted the tolerance from the lower quartile. Okay, so that's it.